Hello friends, in this session we will see solution to state space equation when input is non-zero. Let's begin. Yes, so now so far we have seen that our state equation, that is x dot equal to ax plus b, right? For this we have seen that when our input is 0, when u is our input, right? When input is equal to 0, we have seen that the x of t that we get, the solution of x of t that we have is nothing but e to the power at into x of 0. Is that correct? Yes. And we had talked about that, yes, if you just replace it, I mean, you know that y is equal to cx plus du, right? Again, if you keep here u equal to u, which is nothing but your input, if you put this as equal to 0, then this term becomes 0. The moment this term becomes 0, you have y is equal to c into x, which means just multiply c. And what is your x? Yes, definitely x is nothing but e to the power at into x of 0. So you have c multiplied by e to the power at into x of 0, right? That is what we have seen already. So, and we used to call this one as, yes, zero input response. Am I right? We used to call this as zero input response. Why? Because name itself says that input is zero. Input is zero in the sense it is the response when input is zero. Hence, it is called as zero input response. But now we are not interested in zero input response. What are we interested in is the total response. What do I mean by total response? Let us see. Yes. So now, what do we mean by total response? Total response is what, sir? See dear, total response means that natural response plus forced response. Now, what do we mean by natural response and forced response? Natural response is nothing but zero input response, ZIR, which we have already seen. ZIR is what? When input is not given, when your input is zero, whatever is the output of the system, that is nothing but your ZIR. That is what we have seen already. And now, what is the meaning of forced response? Forced response means it is nothing but non-zero input response. Non-zero input response, right? Wherein your input is not equal to 0, and yes, definitely at that time what is the output? That output means, see, basically just see here, it means that, for example, you have a system, right? You give some input, we have input here and we have output here. Let me consider CISO system only for time being, right? Now, if for example my input is 0, right? The moment input is 0, still whatever is the output of the system. Now you may say that, sir, but input is 0, how can output be there, right? Yes, but that particular output only, when your input is 0, when your input is 0, at that time whatever is the output, your output may be 0 or it may not be 0. You never know. Your output which is there, it can either be 0 or it can not be equal to 0. That completely depends on the internal characteristics of the system. So this is the first one. This is nothing but what? This is called as ZIR, zero input response. Let me write it here. This is nothing but ZIR, right? Now, if rather than giving zero input, if I practically give some input to it, means whatever input I am giving, if it is non-zero, right? Then for that non-zero input, whatever output I get, that is nothing but called as forced response. Forced response. So if you see, the total response that you have is what? When input is not there, what is the response? And when input is there, what is the response? You add them, you get the total response. I know students may say that, sir, but you just said that, if input is 0, then how can we have some output? Yes, you may have some output or you may not have some output. I'm saying may or may not. Each and every word is important. You may have some output or you may not have some output, right? So yes, so now we are interested in the total response and not in the zero input response only, right? So now let us see that how to do so, right? So in order to derive the equation, let us take our same x dot equal to x plus bu state space model, right? Now let me take this ax on the other side. Let me take ax here, so it becomes x dot minus ax equal to bu, right? Now if you see here, is there variable separable feasible here? No. Here if you see variable separable is not possible, because if you see in the previous cases we have done that, right? But now it is not at all possible. So variable separable is not possible. Why sir, why? The reason is very simple. The reason is because this u is non-zero. For now the input is not zero, input is present. So here variable separable is not possible. If you don't know why, please refer your mathematics, right? Please refer that. Anyways, so now let me pre-multiply by e to the power minus 80. Why you are doing it, sir? You will understand it, right? Let us see. Pre-multiply by e to the power minus 80. Why only minus 80 and all? You will understand. Don't worry. On both sides. This is also called as left multiplication. Mathematics concepts, right? Anyways, so basically, originally I have x dot minus ax equal to bu, right? But now to this one I am going to pre-multiply by e to the power minus 80. Pre-multiply, or also called as left multiplication. Left multiplication, right? So towards the left I am going to multiply. Now what I have to check? I have to check that what is the derivative. See, if you just see here, this particular term, if we think of this whole term, now I'm asking you one simple question. Of what function is this green, is this particular function derivative of? Means this particular function is a derivative of which function, that I am asking. Derivative of which function? So this function, if you see, this is nothing but the derivative of d by dt of e to the power minus 80 into x, right? See, yes. So now if you just think of what is the derivative, let me just show that to you, that why it is so, minus 80 into x, right? If you observe here, this one has t in it, yes, definitely. This one has it, yes, because this is nothing but x of t only, no? So this x is a function of t. This particular e to the power minus 80 is also a function of t, and now we are differentiating it with respect to t only, right? That is the reason now this is u and this is v. If you remember, this is 12th class mathematics, right? So it becomes u into v rule. What does it mean? It says that it is nothing but u into derivative of v plus v into derivative of u. That is the rule. So if I apply that rule, what do I get here? I get that, yes, u. What is u here? E to the power minus 80 multiplied by d by dt of v. What is v? V is nothing but x, plus what is v? V is nothing but x into derivative of u. So it becomes d by dt of u. What is it? E to the power minus 80, right? Yes. Now if you see here, this becomes e to the power minus 80 into x dot, because d by dt of x can be written as x dot, whereas plus, yes, again you have this x multiplied by e to the power minus 80, derivative of e to the power minus 80. What does that mean? It is going to be e to the power minus 80 multiplied by derivative of minus 80, which is nothing but minus a, nothing but minus a. So now this term becomes e to the power minus 80 into x dot, right, minus a times x into e to the power minus 80, right? Is it the same? Yes, it is the same. Means, is this same as this one? Yes, definitely. So I can say that it is a derivative of this term, right? That is what is written. So if I try to find out next one is, so now what is there here left is equal to b into u, and this e to the power minus 80 is there as usual. Now yes, now you can easily do variable separable easily. It can be done. So in order to do that, what should we do? Let us see. Let me write down this whole equation again on the next page. Right. Now let us take this dt on the other side and integrate. So if I take that dt, what I get is d into e to the power d of minus e to the power minus 80 into x is nothing but e to the power minus 80 into b into u dt. That is what is there. Right. Now let us integrate on both the sides from 0 to t as usual. Right. So the moment I integrate it from 0 to t, this also I have to integrate it from 0 to t only. Is that correct? Yes. Now if you see here, what has been written? What has been written? I have written that it is d of e to the power minus 80 into x. Just imagine if rather than this e to the power minus 80 into x, if it was only dx, then the answer would have been x, right? But now since it is this one, means this whole term is the variable, dx indicates that this whole term is the variable. So what is integration of this one? This integration of this one is nothing but the variable itself, because see, if I think of integration of dx, what is that? It is nothing but x plus c, right? Now in place of x, if you have e to the power minus 80 into x, then yes, definitely it is going to be e to the power minus 80 into x plus c. So we will have here integration e to the power minus 80 into x is what something we are going to get. But now if you see here, it is indefinite integral, whereas here it is a definite integral. Why? Because there are limits given. Limits are given from 0 to t. The moment there are limits, let me just apply them from here to here. It becomes 0 to t. Is that correct? Yes, definitely. Right. Now see here, which is equal to, now see, now you need to observe one simple thing here. See, here in the first one, if you see the variable which was there, it was e to the power minus 80 into x, right? But now the variable is t, right? And the limits are also from 0 to t. Variable is t. Just imagine that variable is t and your limits are also from 0 to t. Then in such a case, what we do is we do something called as change of variable, right? We will do something called as change of variable, because see, when you are saying that it is from 0 to t and you are saying that this is dt only, so while solving there will be some difficulties. That is the reason we have to do something called a change of variable. What do I mean by that? Just replace the t in the function by tau. You can take a also, b also, c also, d also. It is your complete choice. But then for time being, let me take is at tau. How does that matter? Okay. So if I do that, then what do I have is yes, this integration remains same, 0 to t, e to the power minus a. In place of t, I am going to have tau, right? So I am now going to have a tau. Let me use another color if you want me to be more specific. Yes. Let this be a tau into b into u of tau. U of t, right? This is nothing but u of t only. It is not step signal, by the way. It is u of t, input in time, right? So It was u of t, now it becomes u of tau multiplied by d tau multiplied by d tau. Is that correct? Yes. Now, what I am interested in? Am I interested in these things? Now see, let me just apply limits over here. If I apply limits here on the left hand side, what do I get is just upper limit minus lower limit, right? Upper limits are what, sir? Upper limits are nothing but t. So just replace it is e to the power minus at into x of t. Means x, see this is nothing but x of t only, no? So in place of x of t means it is that x of t at t, x of t at t, right? Minus, it is going to be e to the power 0. Why? In place of t I am going to put 0 because yes. Now next is what? Yes, x of 0, x of 0 into x of 0. Is that correct? Yes, definitely. Now let us do, what do I need to do next? Yes, if you see here, this just becomes e to the power minus 80 into x of t, e to the power minus 80 into x of t, right? Minus I am going to have this e to the power 0 is nothing but 1. So it becomes 1 into x of 0, which is x of 0, which is equal to what? Yes, which is equal to integration 0 to t e to the power minus a tau b into u of tau d tau. Very simple, right? Let me take this minus x naught on the other side. If I take it there, what do I get is e to the power minus 80 into x of t is equal to x of 0 plus 0 to t e to the power minus a tau b u tau d tau. But still, am I interested in this e to the power 80 into x of t? No. What I want is, I want x of t only. So, in order to find this x of t only, what has to be done? I need to pre-multiply by e to the power 80. Let me tell you how. Right. This was our expression. So now let us pre-multiply by e to the power 80. This time it is going to be e to the power plus 80. Right. If I am pre-multiply, what do I get here? Yes. So this e to the power 80 gets multiplied with this plus e to the power 80. Is that very easy? Yes. Now, if you see here, what has happened now? This e to the power 80 multiplied by e to the power minus 80 is going to be 1. So on the left hand side you get x of t only x of t is there remaining. So it is going to be x of t, right? Which is equal to what? Yes, this e to the power 80 into x of 0 is going to be there, right? Plus. Let me take this one inside, this and this. Let me just combine them, right? If I take this one inside, what do I get is e to the power, see here, e to the power 80 into e to the power minus 8 tau, right? If I combine them, because see why it can shift inside, because if you see here this d tau indicates that tau is variable, and if you see in this e to the power 80 I do not have tau is not there, which means it is a constant. So if constant can come out of the integration, then yes, definitely it can move inside also. So now this becomes e to the power 80 into e to the power minus 8 tau. What is that? That is nothing but e to the power, yes, e to the power a into t minus tau. As simple as that, because you know that a to the power m into a to the power n is nothing but a raised to m plus n. Similarly, that is what we have done. So what do we have here? Yes, what do we have here is simple. What do we have here is simple integration from 0 to t e to the power a t minus tau b into u of tau d tau. Now this expression is what you have to remember. You have to by heart this expression. There is no other way. There is no other way because you are preparing for a competitive exam, and for such a exam it is very very important that sometimes you will have to by heart the things as well. Sometimes, not always, sometimes. Right? So this is the equation which has to be by hearted. Now I will tell you the importance or the beauty of this particular equation. What is that? See, if you see this one e to the power 80 into x of 0, what is this? Natural response. Yes, natural response. And what is this whole term? This whole term is nothing but forced response. Right? Why? Because you just have y is equal to c into x of t plus d into u of t, right? You just simply replace it there. You will get the same only. So I can say that it is a natural response and this is the forced response. Between there is plus, which means addition of natural response and forced response will give you total response. Now, what is this x of t? Because see, the response which is there, see, this is, I know that it is a natural state, rather to be honest. But yes, replacing this one directly in this equation, you will, natural response only you will get. No. Similarly, replacing this one here, you are going to get the same. Forced response only. I am interested in what is x of t. X of t, if you observe, x of t, if you observe, what is x of t? X of t is nothing but state evolution expression. What is the meaning? I will tell you. Don't worry. What does it mean? State evolution expression means that from initial condition, of my state to at some value, how my state changed. This is given by this equation. So hence it is called as state evolution expression. How my state evolved from its initial condition to some value at t equals to t. That is what has been shown. Right. This is the whole thing. Now let us take one example such that you will understand it in a better way. Let us do that. Yes. So in this particular question, they are asking you to find state evolution expression. What is that expression? We have seen that, right? Yes. So now this is your state space model which is given x dot equal to 1011 x plus 11 u and x naught. X naught is what here? X naught is nothing but the initial condition. X0 is nothing but the initial condition, right? And u is the input. Now see, u is always an input. It can be ramp, it can be step, it can be parabolic, it can be any damn input. But in this particular example, they are saying that the input that is given is nothing but unit step input. That's it, no problem. Unit step input, yes, no problem. What do we want? Let us write that first. We want x of t equal to e to the power at into x of 0 plus integration 0 to t e to the power at minus tau b into u of tau d tau. This is what we need, right? Now, what is the main expression you need? You basically need this e to the power at first, because do you agree with me that this e to the power at, is going to be very very important thing? Yes. So let us try to find the e to the power at first. Let us do that. So e to the power at, how you get that? It is nothing but equal to Laplace inverse of Si minus A inverse. See, always do reverse engineering. What you are asked to find? You are asked to find the state evolution matrix. What is that state evolution expression? You have written it here. Now you check. Yes, you need this e to the power 80 first. So let us find that, because x naught is given. X naught is given. There is no problem. Similarly, u of tau, it is also given. Similarly, b, it is also given. This is b matrix, right? This is b matrix. It is also given. So if you have e to the power 80, things will become very very simple. Let us do that. So Si minus A, if you see, it is equal to what? Yes, S00S minus, what is A? A is nothing but 1011. So 1011. If you check it out, you get it as this s minus 1. So it becomes s minus 1. This is 0 minus 0, which is nothing but 0. 0 minus 1 is nothing but minus 1. And this s minus 1 is going to be s minus 1. Is that right? Yes. This is si minus a. What I'm interested in, I want si minus a inverse. So si minus a inverse is given by, yes, adjoint of si minus a divided by the determinant of si minus a. Is that correct? Yes. What is the determinant of Si minus A? 1 upon, let us see. This is Si minus A matrix, yes. What's the determinant? Determinant is nothing but S minus 1 the whole square. This S minus 1 multiplied by S minus 1, right? S minus 1 the whole square. Minus 0, because 0 into anything is 0. So, right. Now, what is adjoint of Si minus A here? How to find adjoint? Just flip the diagonal elements, right? What do we say? Flip these diagonal elements. These are the diagonal elements. You need to flip them, right? The moment you flip them, if they are same only, how does that matter? S minus 1, S minus 1, right? And this one, you have to change the signs at their place. So 0 sign change is nothing but 0 only. Minus 1's sign change is going to be plus 1. So this is nothing but Si minus A inverse. If I put this 1 upon S minus A square inside, what do I get? Because S minus 1 the whole square will get divided here. So what do you get here is nothing but s minus 1 upon s minus 1 the whole square, right? Here you have 0, here you have 1 upon s minus 1 the whole square, and here you have s minus 1 upon s minus 1 the whole square. So what do you get here is nothing but 1 upon s minus 1. This is 0, this is 1 upon s minus 1, and you get this 1 s minus 1 is gone, so 1 upon s minus 1. This is 1 upon s minus 1 squared, and this is that. This is nothing but Si minus A inverse. Now, what is the observation? Because see, you need to be very, very observant also. You need to be very agile, alert. If you observe here, at the first instant only you see that the determinant is nothing but Si minus A whole squared. If you know that, yes, Si minus A determinant equal to 0, it gives you what? It gives you poles. Or in matrix you get eigenvalues, right? You get eigenvalues. So if you see here, s minus 1 the whole square, it states that the poles are at plus 1 plus 1. The moment these poles are plus 1, which means on the pole 0 plot they can be plotted on the right hand side. Repeated poles at 1, which is at the right hand side. So this indicates that output is also going to be unbounded. It is a system which is unstable system. That is what we have understood. So yes, definitely output will be what? Output has to be unbounded only. So for example, if in such a situation you have some options there given, so whatever options will become infinite at t tending to infinity, you can choose those options. You can be that observant. Don't worry, I will prove that. Don't worry. Anyways, let us proceed. Now let us, so Si minus, so what is Si minus A inverse? Si minus A inverse we have got from the previous one is nothing but 1 upon S minus 1. What is of interest to me? I don't want Si minus A inverse. I want Laplace inverse of Si minus A inverse. So to get that Laplace inverse, how do I get that? It is just nothing but simply equal to, yes, it is going to be 1 upon S minus 1. What is Laplace of 1 upon S minus 1? E to the power t. If you don't know, please refer control systems transfer function topic, what I have taught you. There you can see that, right? Anyway, this is e to the power at, 0 is 0, 1 upon s minus 1 the whole square is nothing but what? T into e to the power plus t, and 1 upon s minus 1 is nothing but e to the power plus t. Because see, at this particular stage, after learning everything regarding the transfer function, Laplace transforms and all, again doing the same thing is of no use. Anyways, because see, by this time everything you should know, right? Everything in the sense, at least Laplace transform I can expect from you, right? Anyways, now let us use our formula. This is nothing but e to the power 80 as usual. This is e to the power 80, also called as phi of t, phi of 80, right? This is nothing but that. Now let us use our formula and replace everything and see what do we get there. So what is our formula? It is x of t equal to e to the power 80 into x of 0 plus integration 0 to t e to the power a into t minus tau b into u of tau deta. Is that correct? Yes. Now let us simply replace them. What do we get here? E of 80. What is E of 80? E of 80 is nothing but this. So let me replace this e to the power this matrix there. Let me replace this matrix. Let me use another pen for that matter. So e to the power t 0 t into e to the power t into e to the power t. Right. Now next term is x of 0. X of 0 is given as 1 0. This is our initial condition. So it is 1 0. Right. Now next is what? Plus integration, yes, 0 to t. Now e to the power a t minus tau. What do we mean by a t minus tau? See, t minus tau, what does this mean? Because see, initially we know e to the power a t. We want e to the power a t minus tau. What does that mean? In place of t, I have to replace now t minus tau. I'm repeating, in place of t, I have to replace t minus tau. That is the thing which it is saying. Because if you compare, then and then only you will get this expression, right? Anyway, so let us do that. What we have here is, yes, let me just write this with red. So yes, e to the power a t minus tau means whatever is e to the power a t, just replace t by t minus tau. So e to the power t is the first one. So let me replace e to the power t minus tau here. This is 0. Then what is next? T into e to the power t. This is nothing but t. So it becomes t minus tau into e to the power t minus tau. And then again e to the power t minus tau. Right, this is the expression. Now, what is b? What is b? B is given as 1 1. B is given as 1 1 if you see. So, b is going to be 1 1. Now, what is u of tau? See, they have mentioned that u is a unit step input, USI. U is a unit step input. Means for this particular example, it is unit step input. It can be ramp, it can be parabolic, it can be any input. But for time being, for this particular question, they are saying that it is a unit step input. So, if you see, just imagine from 0 to t, what is u of t? See, if I draw u of t, what do I get is, let me tell you. See, if this is u of t, right? This is t and this is u of t. So if you see from 0 to any time t, if you see, it is always going to be 1. So u of tau is nothing but 1. So that is 1 only, no problem. Right? So 1 into d tau. I hope you are understanding this concept. Anyways, let us do. So the next step is what? Yes, row by column, right? First row with first column. What do we get? Yes, e to the power t into 1 is going to be e to the power t. Then yes, second row into first column, what do we get here is t into e to the power t. Rest is 0 because this term is 0. Right, now plus what do you have? You have this integration 0 to t. Right, the same expression what you have inside, let me write. So again, first row, first column, row by column, right? Matrix multiplication. So e to the power t minus tau will get multiplied by 1. So a plus, you get this one as 0. So there is no point in writing that. So what you have is e to the power t minus tau. Similarly, here what you get is row by column. This is row, this is the column. So you get t minus tau into e to the power t minus tau plus e to the power t minus tau. Is that correct? And here you have d tau, right? If I simplify this further, what do I get is, yes. Now here if you see, e to the power t minus tau and e to the power t minus tau are common, right? So now if you take this inside, what do you get is t minus tau plus 1 into e to the power t minus tau. If you want, you can again take this to same and you get t minus tau multiplied by e to the power t minus tau is going to be this term, and then again plus 1 into e to the power t minus tau, you get the second term, right? This is the expression, this is d tau. Now what is important for me is the next one. See, actually this particular problem is so tough, but then it is simple only. No, these are just simply mechanical steps which can be solved easily. Anyways, so yes, now how will you integrate this one? You can integrate easily, there is no problem. How to integrate this second one with respect to d tau? That is the question, right? How to do that? So let me integrate this particular one separately. Yes, so now I have taken the expression here separately. Now if you see here, how to solve this? Simple, by using integration by parts, or students also say that it is u into v rule of integration. U into v rule of integration. Now if you see, what is this u? This u here for this particular case only, it is algebraic, right? Because there, yes, you have this Liet rule and all, right? You all must be aware about it. And now, and the here that you have is nothing but another term, which is exponential term you have here. Here you have exponential term, right? So in such a case, when u is algebraic, how to solve that? I have a shortcut. What is that shortcut? Let us see. Come here. Come here. So you have this u. If you have u into v, and you know that first u is algebraic, rest is what? I don't care. I don't care about v. If u is algebraic now, then there is a shortcut. Copy the u as it is. Take the integration of second term. Second term is v, right? So take the integration of second one. Now you please give alternate plus minus sign. So if this is plus, then next is going to be minus sign. Then take the derivative of the first term. What is the first term? It is u. So derivative of u you have to take. So it is going to be u dash. Let me take. Then multiplied by integration of the second term. What is second term? Is v1. So integration of second term, let me call it as v2. Again, alternate plus minus. So you have to give plus here. Again, derivative of the first term, what is here? U dash, so it is going to be u double dash, right? Then integration of the next term, it is going to be v3. Very simple, right? And you have to do it so on, such that, because see it is a very logical thing. If it is an algebraic term, then yes, definitely after some time, after some differentiation, this particular term has to become zero, right? It has to become zero after some derivatives. Now see, so concept is done. Now let us apply that. So u, what is your u? U is nothing but t minus tau plus 1. Yes. Now integration of second one, what is that? V1. Integration of this v, what is integration of e to the power t minus tau? What is that integration? It is going to be what? It is going to be, yes, definitely, because see, for example, if you have integration of e raised to x, what is e raised to x integration? E raised to x integration is nothing but e raised to x. What is integration of e raised to 2x? It is going to be e raised to 2x divided by 2, which means what you are supposed to do, just simply assume that this term is tau. This particular green, it is tau. If you say that it is tau, it means what? You are talking about e raised to tau. Now, what is integration of e raised to tau? It is nothing but e raised to tau only. So e raised to tau, but while writing, I need to write what is there inside tau. So you have t minus tau divided by coefficient of variable, because here if you see, this is the variable, x was the variable, so whatever was the coefficient of x, that was taken here in the denominator. This is simple integration, which I am, yes, it's okay for me, it's okay, no problem, right? So you have this 2 here which is in the denominator, right? So which means what? You have to divide by the coefficient of the variable. So what is the variable here? Variable here is tau, because d tau indicates that tau is the variable. So here if you see, what is the variable? Variable is nothing but tau. So tau, what we have with tau? With tau I have is minus 1. Minus 1 is the coefficient of tau. Minus 1 is the coefficient of tau. So if minus 1 is the coefficient of tau, here I am going to get minus 1. Is that clear? Yes. Now next. What do I do next? Plus. Now minus. Alternate plus minus sign. First was plus, second is minus, right? So I have taken that minus sign. Now if I integrate it by tau, then what happens? Yes. First one, derivative. We will take derivative of the first term. Derivative of the first term, it is what? T minus tau plus 1. So derivative becomes, yes, it becomes 0 minus 1 plus 0. Right, derivative of t, because t is a constant. See, tau is the variable. How do you know that? Because here we have d tau. So tau is variable, which means t is constant. So for this, derivative is 0. Then for tau it is going to become minus 1, and for 1 it is going to become again 0. That is the thing. Multiplied by what? Integration. Multiplied by integration. What sort of integration? Integration of second term. This second term integration. Yes, integration of the second term. So this second term, let me take the integration of this. How do I do that? It is going to be again e to the power minus t by tau. So it is again e to the power t minus tau upon what? Upon, it is going to be minus 1 is already there. So minus 1 into minus 1 will become plus 1. I hope you have understood this, because again for this particular integration you will get here minus 1, and minus 1 into minus 1 will be again plus 1. Is that correct? So this whole becomes plus 1. So let me just write this again one. So now if I just show this, write this down one more time in a better way. If you see this, we have minus 1 here. Let me just take it up. So if I take it up, I just have this minus into t minus tau plus 1 into, yes, we have this e to the power t minus tau, e to the power t minus tau, right? Now if you see this minus sign which was already there, then again minus into minus 1 is going to be what? Plus 1. So it becomes plus 1 into e to the power t minus tau. Again, minus 1 into minus 1 is equal to 1. We have seen. So this is what we get. Right. Now if I try to simplify this, what will I get? See, e to the power t minus tau has to be common. So yes, definitely e to the power t minus tau will become common. And inside a bracket, I can write that. Now this minus sign, if I send this minus sign inside, what do I get? Plus t will become minus t, right? Then minus tau will become plus tau, and here I will get plus 1 will become minus 1, and yes, definitely, because here it is 1, I am going to get here plus 1, right? So then minus 1 plus 1 will get cancelled. So at the end what I have is going to be minus t plus tau into e to the power t minus tau. Now let me apply the limits now. So it becomes minus t plus tau into e to the power t minus tau, right? If I apply the limits, what are the limits here? Limits are going to be 0 to t. By the way, remember one thing, I am going to apply the limits to what? To tau, because tau is the variable. We have seen that. So let me consider. So in order to apply limits, we first put upper limit minus lower limit. This is always the shortcut. We have seen that previously as well. So If this is the shortcut, here you please put the upper limit and here you please put the lower limit. What is the upper limit? Upper limit is t. So you here you have to put t and here you have to put 0. That's it. So minus t. What I have here? Minus t plus t. This tau will be now replaced by t. So it becomes minus t plus t. Right? See, here itself we have understood that this term is going to be 0 multiplied by this term. Whatever is that term, doesn't matter. I am going to get 0 only. Or let me just write that. For example, e to the power t minus t. Okay, so this is 0. 0 multiplied by anything will give you 0 only. This is 0. Now, minus sign comes down as it is. Then next is what? Next is going to be lower limit. Lower limit is what? Lower limit is nothing but c. E to the power t minus tau is there, right? If I put e to the power t, c, t minus tau, c, let me just write it. Yes. So now minus t plus tau is there, so minus t is going to be there, plus tau. Tau is going to be what? Tau is going to be 0. So tau multiplied by it is going to be e to the power t minus tau. So it is again e to the power t minus 0. So what do you get here? Yes, minus into minus is going to be plus, so you get t multiplied by e to the power t. This is what you get, right? Now if I replace this in our original equation, what do I get then? See, if I replace it here, means here after integrating here, I will put what? I will put my t into e to the power t. And similarly here, what will I put for the first one? For the first one, after integrating this one, what do I get? Yes, definitely e to the power t minus tau. So it is going to be e to the power t minus tau upon minus 1. So minus 1, let me consider here minus. We have done that. So now let me just do the same. Let me just take things very very simple. So yes, definitely if I apply the limits here now, so from 0 to t, what do I get here? Upper limit is what? T. So minus into e to the power t minus tau, t minus tau, t minus t, it is going to become 1 into what? 0 minus lower limit is 0, so it becomes minus e to the power t. So if you see, this is nothing but e to the power 0, so minus into e to the power 0 minus of e to the power t. So if you see, what do you get here is nothing but, if you just observe, it is e to the power 0 is nothing but minus 1 plus e to the power t, right? So it becomes e to the power t minus 1. So here in place of this I will replace e to the power t minus 1. So let us do that. Getting my point, right? T into e to the power t has been replaced, as well as e to the power t minus 1 has been replaced. Now if you just simply add them, what you get is e to the power t plus e to the power t is going to be 2 times e to the power t. So it is nothing but 2 times e to the power t, and this is minus 1 e to the power t minus 1. Yes, and here at down what you get is t into e to the power t plus t into e to the power t. So it is again 2 into t into e to the power t. This is the expression. What is this? This is nothing but x of t. Is it our state evolution expression? Yes. So this is nothing but state evolution expression. This is what has been asked in the question. So x of t is nothing but this one. Now one observation, if you see here, if you simply see here, what you get is, see, when you have this 2 into e to the power t, right? What does that mean? When t will tend to infinity, this term is going to blow out. Similarly, when t tends to infinity, this t itself will go to infinity, and this e to the power infinity is again infinity. So it is all. So basically, what do you understand from this? You understand that the system is unstable, right? Now you please tell me, we have understood that the system is unstable here itself, where here itself we have understood that the system is unstable. We have already done the analysis. So yes, so now we have seen that how to solve the state space equations when input is present. We have seen examples as well. After this, we will talk about a very important topic, which is nothing but controllability and observability. Thank you.